if you're watching at home, you missed turning in the homework. That's what's happened. Here we go. Okay. So we're going to talk about combustion, and I'm going to teach you guys a little trick that actually would have been helpful on last night's homework, but it's okay because it's practice problems. They're not graded for accuracy. It's not a big deal. I am going to pass around. I'm going to give you guys your homework back in a little while, and then I'm going to pass around a key so you can check your work, okay, and make sure that last night's homework looked good, okay? This is our fifth reaction type. This is our final reaction type for this unit. I am going to teach you a sixth reaction type. That is neutralization reaction, but this will not happen until the crash course, okay? So we're finishing this unit today. We're taking a test tomorrow, and then we're going to do stoichiometry. And then we're going to do the crash course, which is the everything else that I haven't taught you yet that you have to know. It's a little bit of gas laws. It's acid-base reactions. It's some thermochemistry. It's just a hodgepodge. It's organic chemistry. It's a little hodgepodge of stuff. Okay? And we do that in a whole of 2 or 3 blocks. Is magic. Okay? So, combustion reactions, fifth and final for this unit. Okay? In a combustion reaction, an element or a compound reacts with oxygen. This is super important. Reacts with oxygen. What is combustion?
It's the flammability things.
It's fire.
It blows up.
Yes? It's fire. If you have a fire and you get a fire extinguisher and you attempt to put it out with the fire extinguisher and you put the flames out, what is it that you are doing?
You're blowing CO2.
Extinguishing it how?
You're taking the oxygen away from it.
You're smothering it, yes? So you are disallowing any oxygen from reaching that because fire can't happen, combustion can't happen without oxygen. It's not possible, okay? So does that being said, does it make sense to you that oxygen would always be one of the reactants? It's going to be something plus oxygen. Like, oxygen actually does the chemistry. Do you understand? It doesn't just need the oxygen. It's not like it's breathing. Although some people think of fire that way, okay? But it's actually consuming the oxygen. The oxygen's actually doing part of the chemistry, okay? So, we have something, and sometimes it's an element, but more often than not it's a compound. It reacts with oxygen, and very often we do combustion, we get heat and we get light as byproducts. Neither heat nor light is actually a product. Like, they don't have, like, what's the chemical formula for heat? There's not. It's an increase in temperature, yes? What's the chemical formula for light? There's not one. It's light. Yes? Okay?
Won't there be light?
Now, one reactant is always oxygen. The other reactant is very often a hydrocarbon. Doesn't have to be a hydrocarbon, but probably 8 out of 10 times when we do combustion reactions, it's a hydrocarbon, which is a compound made of hydrogen and carbon. Hence the name hydrocarbon. Yes? Of different varieties. And we'll look at some as we make our way through the notes. Now, complete combustion. This is super important. And you guys will see this. The practice problem from last night, number 1, read, the complete combustion of propylene. And then yesterday I gave you the skeleton because I knew that you weren't able to fill in the rest of it. Okay? Complete combustion is a hydrocarbon reacting with oxygen, that's what's over on the left, and producing carbon dioxide and water. Those are the 2 things that are always on the right. Do you follow? Something plus oxygen yields CO2 plus H2O. 2 things on the left, 2 things on the right. And all but the very first thing are already determined. When you say combustion, you're saying plus O2 yields CO2 plus H2O. That's what you're saying. Okay? Now, incomplete combustion, which I would not ever ask you to write the equation for that, but incomplete combustion produces some CO2, it produces water. It's something burning in oxygen. The problem is it doesn't have quite as much oxygen. It doesn't have quite as enough oxygen. Okay? So what happens is you will also get soot. which is basically elemental carbon. It's carbon in gas form, at least temporarily, and carbon monoxide. Okay? Here's an example of combustion. This is the complete combustion of methane gas. CH4, this is a hydrocarbon, plus oxygen yields CO2 plus H2O. Complete combustion of methane. When you guys are doing these problems, what I'm going to say to you is, write the equation for the complete combustion of methane. CH4. That's all I'm going to tell you. When I say complete combustion, I expect you to be able to fill in that it's plus O2 yields CO2 plus H2O and then balance. Do you follow? I've said that like 4 times now. I just want to make sure that it's super clear. Okay? Now, incomplete combustion produces carbon dioxide, water, some soot, and carbon monoxide. When does this happen? From a practical sense.
Not everything is burned.
In your everyday life.
Campfire. I have no idea.
Sometimes campfires. There'll be pockets of incomplete combustion, yes. Which is where you get the black smoke.
Factory.
Sometimes factories.
Cars.
What?
Cars.
Yes. Tell the people.
Cars. It's a fantastic movie.
Yes, cars, vehicles
Vehicles.
run on what?
Yes.
Gasoline, which is a hydrocarbon. It's made entirely of carbon and hydrogen. I swear. No, I'm not true. Okay? Octane, which is what gasoline is C8H18, I think. But I know it's C8. That's where the octane comes from. Okay? It is incomplete combustion. Our car's engines are combustion engines. That means you take the gasoline and in a controlled way, you light it on fire. Yes? You burn it. And the energy that is produced from that is what's used to fuel the car. That's what's used to do the work that the car needs to do. Okay? It is incomplete combustion because even though we're allowing oxygen to come in, that's what our air filter is for, by the way, if you guys know cars at all. The air filter filters the air that comes in so that it's not mucky-muck air coming in because gasoline engines are so super clean. But you do want them to be relatively clean, okay? You want to burn the fuel cleanly. But we do get some soot. It should be very little. If you're getting a lot of soot, you probably got some engine issues, okay? If you got some, well, unless you're intentionally rolling coal, which, some of the people like to do. Make sure it's what it is, right? So the more soot, the better, okay? The more incomplete the combustion, the better. But you're going to get carbon monoxide. This is the poisonous, odorless, tasteless, colorless gas that comes out of your car's exhaust. Okay? We do the combustion as completely as possible. We do it as best as we can, but we do have some incomplete combustion going on in our car's engines. If you've ever seen a car, especially on a cooler day, you've been behind a vehicle and there's something dripping from the tailpipe. You guys have ever noticed that?
Yeah.
It's water. Because we're doing combustion and we make water. Okay? So it is water. Now, it doesn't gush out like a faucet, like a garden hose. Okay? But we do make some water. Now. Okay. Best way to learn how to do it is to do it. So here we go. Alright, this is our first practice problem for combustion. And I am going to, I'm going to teach you a couple tricks as we make our way through these. Complete combustion of ethanol, and I give you the formula as I would not expect you to know that. Okay? So, we're going to start with C2H6O plus, complete combustion means plus what? Plus O2 CO2 plus H2O. Ms. Russell, you didn't tell us any of that. Well, yes, I did when I said complete combustion. All right, let's balance. What's wrong?
Mine says glucose, not ethanol.
Do y'all not have this one?
I think you're on the wrong one. Are you sure?
You're on number 3.
Fruit Loop.
It's the rainbow Skittle. Skittle head.
What's that say?
So shut up.
Rush. She's gonna stab you with a pencil. And we're gonna turn a blind eye. Okay, here we go. So C2H6O. Let's deal with the carbons first. How many here?
2.
2. How many here?
1.
1. So let me do a different color. I think that helps y'all. So 2 coefficient there. All right, let's think about the oxygen. Excuse me, the hydrogens. How many here? 6. And here? 2. So we need 3 coefficient there. We have over here oxygen. 1 plus 2.
3.
Okay. And then over here on this side we have 4, 3 for a total of 7. Okay? So we have 3 on one side and 7 on the other. Now, there's a couple ways to think about this. And there's actually 2 methods that I sort of use when I'm doing combustion problems and or anything that contains oxygen like this. Okay? One method is to think about it truly algebraically. Okay? Bear with me, because I'm not a math teacher. Okay? If I put any coefficient other than 1 in front of here, and there's a 1 in front of here right now, correct? If I put a 2 there, if I put a 3 there, if I put a 4 there, it doesn't matter. If I change this from a 1, it's going to change the CO2 and the H2O. Do you appreciate that? Yes? Okay? So I want to, and you have to put coefficients in front of the thing that you're burning in combustion often. Okay? So you can't just avoid doing that altogether. But there is a way to think about this where I would not have to actually change the coefficient, which is a 1 that already exists in front of the ethanol. Okay? So here's what I want you to think about. This 1 is right here. Okay? It's over there. No matter what I do, this is going to be a 1, and this is going to be a multiple of 2. So I think about it like 1 plus 2x equals 7. Do you follow what I'm saying? What I'm saying is I could put a coefficient here, the value of which could be equal to the x. And I would only be changing this oxygen and would not be changing this one over here. So if I was going to solve for x, what would I do? If I was going to solve for x,
Minus 1 divided by 2.
okay, so I take each side and I subtract 1, so I get 6. 2x equals 6. Divide by 2, x equals 3. 3. Two carbon, 6 hydrogen, 3 times 2, 6 hydrogen, 1 oxygen, plus 3 times 2, which is 6. So 7, 4 plus 3 is 7. Ethanol is, it's actually a liquid, but you could put gas and not get it wrong. This is definitely gas. This is definitely gas. The water that comes out of combustion reactions is a vapor. If you see water dripping out of a tailpipe, it has condensed. And you have to think about that. Whenever we have water, we always put L, unless it's a combustion reaction. If you say that combustion makes liquid water, that would imply that when you have something burning, water is running off of it. It would be cool, but is not how it happens. Okay, so it's water vapor. It is water in gas form. Okay? And then ratio 1, 3, 2, 3. Yes? Moving on. Numero dos. I'm going to show you my another trick on this one. Okay? Complete combustion of benzene. C6H6 plus O2 yields
CO2 plus H2O.
That's our skeleton. All right, let's talk about the carbons. 6 carbons, 1 carbon, so I need a 6 coefficient in front of the CO2. 6 hydrogens, 2 hydrogens, I need a 3 coefficient there. Now we got to deal with oxygen, yes? Okay. How many oxygens on this side? 2 oxygens. How many here? 12. How many here? 3 for a total of? 15. No matter what I put in front of this oxygen, this thing will be a multiple of 2. Do you understand? No matter what. Now, if I was thinking about this algebraically, 2x equals 15. What would that be algebraically? Yes?
Please tell me we're allowed to do that.
No.
Gosh darn it.
But you are for a minute.
Okay.
Okay? Can I have, remember that coefficients are moles. They are mole ratios. Can I have a half of a mole? No, because I can't have half of a molecule. Okay? The O2 has to remain. However, this with the 7.5 right here, at least figuratively, gets me to where I want to be. So I can have the 7.5 when I think about it from a math standpoint, and I can have that for a hot minute. That has to go away. We want to maintain the lowest whole number ratio here, so we're going to take the coefficients that exist as it stands right now. It's 1, 7.5, 6, 3. This is my ratio. Fastest way to get rid of this and have a whole number is to multiply everything by 2. 2, 15, 12, 6. Is this a reducible ratio? No. So my final answer is 2 C6H6 plus 15 O2 yields 12 CO2 plus 6 H2O. Final ratio. Benzene is a gas. It varies. This is gas. This is gas. This is gas. Putting a decimal number in front of the O2, you could have done this twice on last night's homework. There were 2 occasions, number 1 and number 6, the very first and the very last, on last night's homework where you could have done that and it would have been helpful maybe. Yes? Now we're going to do glucose. Haywood.
This is the only one I know. What else? You add water and CO2?
For what?
Photosynthesis. Glucose? No, glucose is what you get. You add sunlight, water, and CO2. Right?
CO2 plus H2O.
Yeah.
In the presence of sunlight and chlorophyll.
Yeah.
Those are above the arrow.
Yeah.
Yield C6H12O6
Yeah.
plus O2.
I read that once.
You remembered C6H12O6.
That's what I remember. The important part, sugar.
Sugar. Okay.
Sugar.
All right. So, C6H12O6. Smartboard is so fun. Plus O2 yields CO2 plus H2O, complete combustion. Carbons, we got 6 and we got 1, so we'll put a 6 coefficient in front of CO2. Hydrogens, we got 12 and 2, so we'll put a 6 coefficient in front of the hydrogen in H2O. Now, we have 6 plus 2 equals 8. How many are here?
12.
How many are here? So we have a total of what?
18.
18 on this side. So we have 8 on this side and 12 on this side, or 18 on this side. Now, listen to my words. Do you appreciate that if I put a coefficient in front of here, in an effort to make me have more than 6 oxygens here, it's going to mess up the CO2, it's going to mess up the H2O. Do you appreciate that? Sometimes we have to put a coefficient in front of this thing that we're burning, but we don't necessarily have to. Okay? Okay? It's a good thing the camera's rolling, that's all I gotta say. Okay? So 6 plus 2 equals 8, 12 plus 6 equals 18. If we put a coefficient in front of here other than 1, it changes everything. So, and this, whatever goes in front of here, this has to be a multiple of 2. So, 6 plus 2x equals 18. 6, 2x, I'm trying to figure out what is this. This is my x, equals 18. So we subtract 6 from both sides. 2x equals 12. Divided by 2. What's glucose?
One.
What state of matter?
Solid.
Gas. 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 Ratio 1, 6. 6, 6. Yes?
Can't take it. I believe in God.
Okay.
666. Can't take it.
What does your next slide say? Cumulative problems, write, balance, and type the following. See, look, mine says nothing.
Oh, man.
Cumulative problems and it's blank. I don't know what that's about. Whatever.
Okay.
All right, here's what I want you to do.
Separate paper, right?
I would separate paper, yes. People at home, we're working on this bottom slide right here. This is what you're doing. You already have your copy of this. People at home, we're working on this now in class. Thanks. Talk to you later. Bye.